Hey there, welcome to Learning Labs. Today we're in meteorology. We're talking about weather, and specifically we're at 2.4. We're all talking about water vapor and humidity. Here are some of the terms we're going to discuss. Let's jump right in. All right, first question on the list is, where does water vapor come from? Water in the air is called water vapor. Water vapor is water in the form of gas. The amount of water vapor in the air is called humidity. The changing of liquid into gas, water into water vapor is called evaporation. You probably heard of that one before. That's grade 4 stuff. To do this, it takes a lot of energy. You probably boiled some water before to make some ramen noodles. That's what we're talking about. All that energy to get that water hot enough to swap it from liquid into gas. It takes a lot of energy. Condensation is the changing of the gas back into a liquid. Okay, so you heat up water to turn it into water vapor, to gas. To turn gas into liquid again, you do the opposite. So you got to cool it down. We're going to see this in a bit. Here's an image of the water cycle simplified. Okay, you have water in the bottom in the lakes and the ocean. It gets heated up by the sun, goes up into the clouds, cools down. If you watched the last episode, you'll find out that as you go up, it gets colder. Eventually the water gets cold enough that it turns back into water, okay, and it collects as a cloud. Cloud gets heavy enough, it pours back down as water droplets, okay, rain or snow. Relative humidity. Okay, this one is getting a little bit crazy. What are we talking about? Relative? It's got relatives, ancestors, and cousins and stuff? No. We're talking relative in a different type of tone. How much water vapor is in the air versus how much water could be in the air. Okay? It's a ratio. What? It's crazy. It can affect how someone feels in the air. So if there's a higher relative humidity, there's less water available to put into the air. The higher the relative humidity is, less water can evaporate into the air. Okay, so if there's high relative humidity, that means that there is so much water already in the air that no more can be evaporated into it. Okay, it's already maxed out, can't hold any more water. That means it's high relative humidity. So that's why when you go to Mexico and it's a really humid day and you're sweating, it's so hot and you feel sticky, it's because the sweat is staying on your skin and it's not evaporating. So it makes you feel sticky because it can't go into the air. What happens when warm, moist air cools? Okay, this is what we're talking about when we evaporate water and it goes up and it cools down. What happens there? So the air gets colder with increasing altitude. Heating the air also causes it to rise. So your parents probably told you hot air rises, right? That's why you should stay in the basement when there's a heat dome, especially in BC when it gets crazy hot. Sun heats the air above the ground. And it warms, and then it rises up. Warm and cold air don't mix. So the warm air rises, and it pushes past the cold air and pushes the cold air down. The lighter warm air pushes over the heavy cold air, and the warm air pushes higher into the atmosphere and cools down. The air rises, and water vapor condenses into tiny water droplets forming the clouds. So here we have warm air rising above the mountains. Okay, in the second picture we have warm air just going straight up and forming a cloud. In our third we have cold air underneath the warm air forming a cloud. Underneath this video is linked into our lesson links where you can practice some of the stuff we've been talking about here and solidify your understanding.